All right, I think we'll get started here. Good afternoon, everyone, and welcome to today's Wednesday webinar with Rita. My name is Charles Cronschnubble, and I am the Executive Director of the Western Regional Innovation and Technology Alliance, or as we like to call it, RITA. RITA brings together public sector technology leaders across our seven-state region to collaborate and share practical insight and strengthen the systems that serve our communities. In today's session, we have A&M's Director of Data Center Cloud, David Abbott. He's going to be covering next generation disaster recovery, architecture, automation, and resilience, which really speaks directly to the challenges many of us are navigating right now. So we are pleased to have our platinum partner, A&M, leading today's discussion, and we are excited to welcome them into the RITA community and look forward to the expertise they're sharing with us today. With that, I'll turn it over to David.
All right. Thank you so much. Yeah, great to be here today. So yeah, I'm David Abbott, Director of Data Center and Cloud for A&M. I also operate as a principal consulting architect across disaster recovery and resiliency within our customer base. A&M's just a local VAR located out of New Mexico, Colorado, Wyoming, Arizona, kind of West Texas, Utah, and North Carolina. And we cover a lot of customers within the public space as well as private sector, and providing a lot of different really technical-led solutioning and services for different IT solutions here. So today, yeah, in the next hour, I'm hoping that you walk away with really three things. I mean, a practical definition of what next-gen disaster recovery is and how that really ties into cyber resilience, as well as kind of a clear model for how you can layer resiliency, disaster recovery, secure infrastructure, data protection, and DR and networking all in to really build a incremental approach towards increasing the resiliency of your organization, helping you recover in the event of a disaster. And then hopefully really a short list of actions that you can take in the next 30 to 60 days to materially improve your recovery outcomes. So let's start and jump in really why this matters now, today, within your environment specifically. If the screen will advance for me, there it goes. All right. So within pretty much any IT organization, it's no longer, a safe space where if I have resilient hardware and systems that, hey, I can keep stuff up and running for the most part. Downtime just isn't hypothetical anymore. There's cyber attacks, which are kind of a leading threat to many organizations. You might have infrastructure failures, user errors. You might have a cloud outage, power and cooling failures, natural disasters. All these different areas can impact IT systems, which means that your business processes go offline. You cannot function if these are down. And in today's world where you're not necessarily an IT company, but you're a company driven by IT, this can be really devastating to any organization. You're talking financial impacts. You may have goodwill or reputational impacts, legal or regulatory. If you're, dealing with public safety, you might have health or safety risks, or you just may not be able to meet the business objectives you're trying to achieve. And really today, it's no longer just your data center. You've got campus and edge locations that are maybe critical. You have cloud infrastructure locations where maybe you've got applications running up there that also have to be protected. Or you have SaaS applications within the cloud that you have to be thinking about how you can work around and continue functioning if you had a data loss event in there. Not simple anymore, and we know this could happen. Number one probably issue that we see across our customer base is typically cyber attacks, and a lot of these are very destructive. So when I say next gen disaster recovery, what do we really mean? A lot of times we start out with the concept of cyber resilience. So cyber resiliency, it's kind of made up of four areas that fit very well into building a advanced disaster recovery and resiliency strategy for your organization. And there's four goals that are defined out there within a NIST framework. And there's the MITRE group has got a framework around this as well. But really, it's starting out with the whole concept of anticipating what could happen. And this is where we're trying to get ready to reduce the likelihood of any potential outage and really reduce a blast radius if we had a security incident inside the organization. This is done through things like security hardening across our systems, basic segmentation, identity controls, monitoring so we actually know what's happening in the environment, having comprehensive data protection and maybe DR replication if our data requires it. Having the plans created ahead of time so we've actually thought through how would we get back? How would we recover if something did happen? And then training our teams on it so they're familiar with it, testing so that we know stuff works, and exercising those so that the broader organization understands how this happens. That's great. That helps protect you. But if something does happen, you need to be able to withstand. You need to try to keep as many key critical systems functioning as possible. And this is where technologies like high availability or redundancy come in place, where maybe isolation of key management systems and control planes is critical, or having quick action plans where you can very quickly step in and isolate parts of your infrastructure. You can stop the bleeding very quickly without going and spending 2 or 3 hours being like, what do we do first? Who do we call? How do we start moving on this? Those are key all to helping you withstand any potential outage, issue, or especially cyber attacks. All right, so if we had something happen, and inevitably, if we said that, yes, we're going to have outages, we should expect it. We're going to have cyber attacks, we should expect it. Then we need to have some way to be able to then recover. And this is how can we restore our services safely and as quickly as possible. So we have things like cleaned and ready recovery environments. Our data is clean and available. We know what data is there. We have orchestration to help us get everything back up and running. We have even validated and practiced recovery processes, going back up to that whole anticipate phase where we know stuff will work when we have to click the button, or we know generally how it should work and we can quickly adapt if there's gotchas or unexpected activities because we've practiced it. And finally, that fourth pillar is really got to improve continuously. Cyber resilience, disaster recovery, high availability, any of these technologies, it's not a set it once and forget it. It's a continual roadmap you have to be following. That's where we take that training, testing, and exercises. We build roadmaps. We create risk registers. We track metrics so that you can get better incrementally. Otherwise, it's just going to fall to the wayside. And when you do have a disaster, you're going, oh, I didn't update those plans in 4 years. We don't even run that system anymore. That doesn't help anybody. And it's certainly not going to help your organization. Now, I'm sure if you've listened to the marketing and you hear all these different companies out there, cyber resilience has probably come up like, hey, you buy our product, you've got cyber resilience today. The reality is cyber resilience is not a product at all. There are organizations that help to introduce cyber resilience as part of an overall program, but really it's not something you buy, it's something you build. And it's done through a result of multiple layers within the organization working together. It's, having that security program. It's having that secure and resilient infrastructure built. It's having data protection that's fully secure and immutable that we can actually restore out of. It's that planning we have around disaster recovery or the capabilities we've built to match our organization's requirements. But it's also then, hey, we got to get to stuff. So resilient networking so that I can actually access systems back up and that's going to maintain online. Or secure networking so that we can, again, limit the blast radius within an environment. So while it's not a product, it's really built of a lot of essential tasks and capabilities that we do a lot of today. It's now just evolving some of those and adding a few extra layers to them. So how do we get started with cyber resilience? When we look at it, number one piece, really with any project or any type of new technology within the data center is that you got to start with that secure foundation. And cyber resilience is no difference. I mean, a lot of it is just boring stuff with cyber resilience, but it's essential IT disciplines that we need to do. And I'm going to cover a few of them here that are foundational that I run across pretty frequently where we keep trying to do it well and we keep struggling, but they're the areas we can have the biggest impact and actually use to help us build disaster recovery as part of it. So the first one, the good old life cycle and vulnerability management. And this is really, well, we got to know what's in the environment and address vulnerabilities based on risk. So that's we inventory our systems, software, data. That's useful for both the cybersecurity side of the house. I mean, you can't protect what you don't know what's there, but also on the data protection side of the house and the DR side of the house. Again, I can't actually back stuff up and have recovery paths and proper recovery capabilities if I don't know what's there. It's that patch cadence, and not just your operating systems, but your entire infrastructure. We need to be patching and updating. And this is a great way to actually start to test failures. What happens if this system goes out? What is it impacting? What are we constantly having to fix? I was working with a larger organization recently and talking with one of their engineers around their patching and how they were continually having outages as part of it because they didn't understand the interactions within their own systems. Crazy thing is they've been doing this for like 4 years and having an outage every single time, and nobody thought to stop, slow down, document what they were doing in this patch, what was failing, and start to build a map around that. So vulnerability and management, I mean, we're causing deliberate outages when we patch stuff. It's a great time to start evaluating your environment for where do I have weak points? Where do I have single points of failure? Where could I improve? Now, of course, technology doesn't last forever. So we need to also have that end of life planning. Because if systems go out of support, out of security patching, that puts us vulnerable. You look at like VMware with their recent vSphere 7, where it went end of life. There's still a lot of organizations running on that, but it's not getting updates. It's becoming a bigger and bigger target out there because, again, attackers know that, well, that's not really getting patched. I bet if I find a new vulnerability, it's going to take VMware forever to even want to patch that old of a system. Just leaves you vulnerable. Same thing with network devices, same thing with storage systems or critical infrastructure across your environment. Our potential for failure and extended failure increases the older stuff gets, the further it gets out of whack from our current versions. All right, next one is that we kind of need to know what's happening on our systems. This is the good old logging, auditing, monitoring. It's foundational. Hopefully everybody's got, next gen endpoint protection on their operating systems out there. And that's reporting up to a central location, and hopefully somebody's watching it. That probably gives us good visibility into what users are doing on critical systems with the logging all centralized, gives us visibility into where threats might be popping up or where we might have compromises. But that's only part of it. What about all of our infrastructure systems, the key critical devices that run our infrastructure? Storage systems. Do we know if somebody's been trying to log on to the management interface of my primary storage array? What about my backup system? What about my hypervisors? What about the firewall interface? What about the network switches? We want to have all that logging centralized into either like an MDR solution, or if you've got your own SOC internally where they're able to watch that and monitor it. Now, beyond just knowing what's happening inside of our systems, we need to be monitoring them for capacity and performance issues. Today, this is a benefit if we're monitoring capacity and performance because it means we can also right-size our environments. IT is not getting any cheaper out there. I mean, I look at memory prices right now and I go, wow, if I need to add memory to somebody's cluster, that is brutally expensive. Versus maybe we just run an analysis and right-size everything in there and actually do capacity management. It means we don't run out of capacity, our systems keep running as they should, and we're starting to reduce our costs a little bit. And then the other thing with monitoring systems, we can do that dependency mapping. I mentioned that patch cadence, all right, we're starting to build an idea of what gets impacted, but we can also do that with our monitoring systems. We patch something that goes offline, I see what else shows up red around it and go, oh, well, that's probably some dependencies. And I can start to document that, record that, and build that into my monitoring system so I get a clearer picture of what truly has failed if we have a major outage. So these two can really help each other quite a bit. Now, the next one that amazingly enough that I see over and over again is that IT shops, organizations, they get in the shiny new piece of technology and they just deploy it. and they don't really think about, hey, what's the security implications of that? Is there a secure configuration I should be putting on it? If you think of like a Windows operating system, it's delivered to you, that computer delivered to you to be as easy as possible to use, but definitely not secure. You've got to go through and harden that system up. The same applies for anything within your infrastructure. Doesn't matter if it's your cloud environment in AWS, in Azure. It doesn't matter if it's your VMware environment, Hyper-V, if it's your storage systems, your servers, your networking gear, your firewalls. All of those have recommended ways to go and really build a secure configuration around them. This limits our blast radius substantially by using some of these good practices. But then you've also got to keep that secure configuration up to date. If you think again, Windows servers, group policy objects, well, you've probably had over time where you've had to adjust your policies to disable things like older versions of TLS or SSL. That's one way you're keeping secure configurations up to date. You'll see the same recommendations appear frequently for your infrastructure systems. So if we can find out where they're updated, and maybe once a year we go and check, are there new practices I should be following? Or you talk with your partners like ANM and say, hey, I've got these devices. I know we deployed them a year ago. Is there anything I should be thinking about updating or hardening further? It's a great way to continue to evolve that security posture and better configuration hygiene. And a lot of newer systems also opting for security, especially like backup systems, storage systems, heck, your hypervisor platforms, cloud platforms. All of these have tools to help you manage that configuration securely and manage drift around it. Now, finally, just the basic one, right? Good architectural practices. If you haven't changed or evolved your architecture since how you built your infrastructure, say 20 years ago, you probably have some challenges there. We have to continually change and adapt our architectures to prevent a buildup of technical debt. Technical debt is just painful in a disaster recovery scenario. That is usually the one area where we are fighting the most when we go to build it, or we're doing testing, or we're trying to do failover, or we're trying to do advanced recovery. Is that technical debt is a challenge. It's usually because it's not supported, or it's nobody knows how it was built, why it was built, how to build redundancy into it. We can also go in and follow vendor and industry good practices for how we build things and evolve things. So if you've got two data centers, you're like, yeah, we're still using basic layer 2 stretch across. We've got spanning tree and we're using HSRP, but we can't really fail over other pieces and we have lots of single points of failure. Maybe it's time to evolve that architecture and use the best architectural practices for today. Also look at security. Anytime you're putting stuff in, security should be considered into the design. Is this solution making me more secure or less secure? How can I make it more secure? How can I feed back into that configuration hygiene and make it more secure? And finally, always keep in mind and look for opportunities where you can simplify. Complexity is killer in disaster recovery and resiliency. The more complex it is, the harder it is to recover completely within that time frame, and without having your teams run around having to do superhero antics to bring systems back online. If it's simple, easy, and we have simple processes to be able to bring stuff across, you stand a much better chance of having success. All right, so good foundation. Now, going beyond that is how do we start to take some of those concepts, such as in good architectural practices around like security? If you went into the environment today and said, hey, do I have a user workstation? Could it ping, reach, somehow or other scan the ports on, say, my backup systems management server, or on my data storage management interface, or on my network interfaces? Could an operating system in the data center access those same interfaces? Usually what we see in a lot of environments is the answer is, yeah, we can. Our network's kind of like Kansas. It's really flat, it's open. We don't have a lot of segmentation inside. We still have that squishy inside. We know it's a problem. We know it's a challenge, but it's too big of a problem for us to figure out how to solve. We hear that a lot. The reality is though, start small, start easy. One of the easiest things to start to segment out in your environment is management and control plane ports. When you think about it, when a recovery goes sideways, especially in like a cyber attack, the cause isn't always a lack of backups. It's that the control plane was fragile and exposed. I mean, that's like identity systems, admin access, management networks, your hypervisor consoles, stuff like that. And then attackers or a simple mistake were able to reach that and able to do destructive operations. So if we start with a simple principle and say, we want to isolate and protect our management plane for our key critical infrastructure like it's a tier 0 asset because, well, it is a tier 0 asset. It is more important than everything else above it because if you blow it away, nothing else above it exists. So the first way to do that, a simple way to go about this, is to start to isolate those networks. So we take our areas such as, our management interfaces on our network, our storage systems, our data storage arrays, and we put them behind a firewall. We don't even need a big firewall. We can use an edge firewall or extra capacity because this is small management calls. It's not a lot of traffic, fairly easy to isolate, but it gives you exponential levels of protection just by blocking so that your users inside your environment and just your general applications, data, and OS is where we have the most risk from accessing those. We can block that risk, that helps exponentially. Same thing with backup systems. I mean, the reality is backup systems, we don't want to have relying on production. They should be isolated. They shouldn't have direct network access into them except for data movement where they need to. But management interfaces should probably go through either a couple workstations that are authorized or secure jump boxes or something along those lines. An easy way to get started. You can always go deeper in the future and start to look at how we then segment or do micro segmentation of my operating systems and application and data. That's going to introduce cost. It's pretty easy to go through, spend the labor, spend the time, especially if you're doing life cycle updates or if you're replacing systems or you've got major upgrades going, and just start to segment off those management areas. Now, challenge is a lot of times attackers are not necessarily hacking into environments. They're logging in. So the other piece that we have to do with all of these key infrastructure systems is now protect that from an identity and a privilege access management perspective. One of the easiest ways to do this, well, maybe not easy, but one of the easier ways to do this is to actually separate out authentication planes. We're so used to having our user domain sitting right next to our infrastructure domain. That leads to a lot of problems where if we have user compromise, where even if we have MFA and user compromise, they have a clear path into our infrastructure systems that are housing all of our data, that are protecting our data, that are running our systems. If we can separate that out into its own AD forest that's completely isolated, we can stop many of those user-based attacks because that's maybe 10, 15 admin accounts in that entire domain that are all tightly monitored, watched, and controlled. Now, if we can't go to that level, just having multi-factor authentication on every single supported system. If your storage array doesn't support MFA, it's probably getting too old. If your backup systems don't support MFA, probably time to upgrade. Same thing with infrastructure systems, networks. All of these areas can support at least MFA. If you want to go further and you still don't want to do a separate authentication domain, there's privilege access management systems that can kind of act as a broker, where it's doing all the proxy connections and logging into your devices. Your users are not. It, again, protects it a little bit more. It definitely gives you an advantage where user accounts shouldn't be able to compromise it easily. Many organizations already use separate admin accounts. Challenge is if somebody gets a main user account, gets a password scraper on a machine or something like that, they might see an admin account pretty easily. Not as the most secure, but definitely better than using user accounts. But really across any of these environments, what we want to be doing is auditing and user monitoring for all those powerful accounts and groups. Really, if somebody's failing to log in a few times, I know I fat finger my keyboard, that should still be something that gets flagged in the SOC. It's like, hey, there's an admin account that's tried now 4 times to log into the storage array. This could be a problem. Address those quickly. They need to be monitored. Backup systems take a whole nother approach where really these ones should not at any point in time be on your production domain. Again, backup systems should not rely on production. We want them to be isolated. Doesn't matter if it's a local authentication across the board, if it's a SSO authentication up to a cloud, so like Entra ID or Duo or something like that. And then also having that auditing, logging, monitoring on those backup systems as well, so that we can identify any sort of potential user compromise. We have to treat those backup systems and our primary infrastructure as completely critical. We don't want to let an attacker potentially get in where we could compromise that secure foundation. All right. As you continue to advance, especially in public sector, you've bound by now been just hammered by zero trust this, zero trust that here. I've got a product for zero trust. It's a lot like cyber resilience. The reality is, though, it has some great principles and capabilities to at least get you thinking about how do I reduce trust in the environment? How do I make it a little bit more secure where somebody that logs into my workstation in an office doesn't have full network access into the data center? They may not have credentials, but they've got network access. Or a user account that comes in on a VPN has access to everything or too much. Or that our data is not properly inventoried, managed, encrypted, categorized, protected. So there's a lot of different ways in zero trust as you continue to evolve that are completely relevant to cyber resilience. We didn't want to go in too deep to this today. If you're interested in learning more, we do have workshops around this here that are free of charge. It's like a 4-hour workshop. We can come in and talk to you in depth on zero trust if you're interested. All right, zero trust, great. Security, secure foundation. I still mention that we need to have data available. And cyber resilient data protection is really the whole concept of that we need to have data protection that's good for somebody deleting a file, a malicious actor encrypting a file or deleting a file, or maybe a whole data center blowing up. And really the concept is that backups really they're completely worthless to you if you can't actually restore what you need quick enough so that your business can operate. And that data, especially in a cyber attack situation, is actually accurate, complete, and isn't reintroducing the exact same malware or problems into your environment. Now, it's very different than how we used to treat backups. Backups used to be oh my goodness, I don't like backups and I don't want to have to deal with it. It's just some system that puts stuff off onto tape and we recover from it like once every 3 years, or sometimes we recover this local stuff when users delete a file. That's it. It's really not what they're there for anymore. That's great features to be able to have users restore their files, but it's really to protect the one thing in your business that you cannot recreate if it's all gone, and that's the data. It's important to have. It's critical to an organization. I can rebuild networks. I can rebuild servers. I can find new equipment. I can't find new data. I had 10 years of historical data that's driving a product or driving a customer's solution and it's gone. I'm not getting that back. Now, I might have paper backups in some cases, but good luck on trying to get that ever digitized and functional again. It would take you years. So we want to protect the data as best we can. Now, remember, backups are not resilient just because you have them. They're resilient because they're very well protected and they're not in that same blast radius as production. They should be separate, which means we need to have, if you follow the good old methodology of 3-2-1, we have 3 copies of the data somewhere. I've got a copy off site, maybe to a replicated storage array. Maybe I've got now a backup copy at one site, and I have another backup copy that I've pushed off into the cloud. Cool, 3 copies of data. 2 different types of media. Don't have it all on the same thing. Don't have just 3 different storage arrays that are all the same brand, and that's your 3 copy of data. We get a compromise on one, they can probably compromise all 3, and we may lose that data. A copy off site. This has gotten really easy these days. It used to be the nightmare of trying to rotate tapes. Now it's, well, I configure my backup solution to push a copy up into Azure, AWS, Wasabi, or any one of the other online solutions out there that's going to be immutable by nature. That gives me that offsite copy that I can ramp up bandwidth locally to be able to actually pull back quickly. The big one there is copies that are immutable. This means that I have copies, ideally one on-prem, and then that cloud copy where an admin or a malicious actor cannot change, delete, remove, damage that data. Or if they can delete it, that it's still there. It's just maybe hiding the flag if it's like a cloud environment with lifecycle. What we want is to make sure that we can always recover, whether it's on-prem or cloud, and that we have that data available. Now, beyond that, having data copies is great, but there's a tool that makes data copies, right? You've got your backup solution. So similar to the infrastructure, we need to make sure that we're hardening that configuration of data protection infrastructure. If you're running Veeam, you should be thinking really hard at how you harden that system up. You're running a modern system like Rubrik or Cohesity that are pre-hardened, it's a little bit easier. But it's making sure that you can address the security of that data protection infrastructure. Authentication, MFA, least privilege, that's all, table stakes that you should be doing on data protection solutions. Multi-user authorization. Some call this like two-hands authorization. Some of this is a workflow authorization, but this means that one user can't go in and do a destructive operation or change a policy that would reduce retention or anything like that. It has to go through a secondary user to authorize it. That in itself solves a lot of data integrity issues. And then, of course, network segmentation and control. We don't want to have backup systems exposed to everybody. They need to be segmented off, isolated, and really tightly controlled as to who gets access. All right, that's great. What about actually making sure we're protecting all the data? I recently worked with a fairly large transportation customer that would impact a lot of people if they had an outage. And they went through and we audited their entire environment. And we found that, well, they had a third of their systems, many of which were big, massive production file servers and application systems. They had zero data protection on them. And they didn't realize it. And they didn't have really any documented SLAs to say that they needed to be protected. But through discovery, we found that, hey, if those went down, that business probably would not exist in a few weeks' time. So making sure that you actually align data protection to your SLAs and that you're managing and monitoring and validating that you are actually protecting the data you need. That you're auditing and logging activity on the data protection infrastructure to make sure that you don't have people in there doing stuff they shouldn't be. And that you're monitoring those data protection jobs because, job failures in the past are like, oh, that's annoying, I'll get to it in a week. Today, you have to treat that like that's potential data loss. If that job fails, you could have data loss if you had an attack today or if you had a disaster. So addressing those as though it's truly a critical tier 0 system is important. Now, protecting data is good, but I mentioned if we can't get data back and restore it, we're not really in any sort of good place. So we have to have some recovery strategies. First off, we have what you're all used to. That's that traditional data loss where, hey, you know what? I'm going to restore data from my backup system. Yeah, my main storage array, maybe it had a pipe break above it and dumped a bunch of water on it and fried it. I'm going to go to my DR site. I'm going to restore some data. That traditional data loss scenario, we assume that backup data is good, clean, and fine. We just have to find the latest good version of data, and we restore that onto our existing good infrastructure. Where this changes is when we get into cyber attacks, because now you no longer have that concept of good data. It is now that backup data is suspect. It's a little suspicious. Is it clean? So we have to be able to peel back and look through our backups and find clean data to be restored while limiting data loss as much as possible. This isn't that I'm going to go back 3 months before the attack started or got in my environment and restore that, because then I'd have 3 months of data loss. This is, all right, I need to find the latest good copy of the data I need, and then maybe find a good copy of the VM that has that data, and then restore the two in sequence, and then clean it up, or I restore the latest and I clean it. It's a very different process for a cyber incident than it is for traditional data loss. Not only that, where are you going to restore it? If you had a cyber attack in the environment and you've got incident response there, you might run into suddenly that, well, my infrastructure is suspect too. So I need to go clean systems during restore. I need to go clean my infrastructure and get it back up and running and back to where it needs to be. This is why it's so critical to have some of that separation around network segmentation and identity layers, because it reduces the risk of this actually impacting all of your infrastructure. Your data might be gone, but your infrastructure is protected. Similar to in the cloud, where AWS doesn't let you touch the actual underlying storage arrays or underlying hypervisors. They protect that from you. Now, with either of these, really, backup data visibility is critical. You need to understand what's in your data. So if I'm trying to do a restoration during a cyber incident, it's really nice to be able to take Yara files and drop them in once the incident response team's identified all the potential exploits or malware, and look across my data as to where that exists. Or to be able to understand the risk. If they exfiltrated data, I want my backup system to tell me what was my risk exposure within that data. Did I have PII data? Did I have HIPAA data? Did I have PCI data or anything like that? It's great to have your backup systems able to identify that up front. And a lot of the systems today can do it already. You may need to upgrade. You may need to examine if you've got all the features turned on, but it's good to take the time and do that to see if they can actually enable these features. Anomaly detection is another one. Backup systems typically are looking and examining your data every time they back it up. They're doing indexing operations. They're looking deeply through it to make sure it knows what's in each file, how to restore it so that you can actually get data back out. But a lot of the newer ones are also incorporating anomalies. So they're like, wait, I'm starting to see encryption rise on certain areas in the data. I'm seeing huge deletions starting to occur. I'm seeing large mass change of records that's outside the norm. I'm going to flag that. It means you can actually start to identify or get another avenue to identify potential attackers or mistakes or insider threats within the environment. Now, okay, so we understand what's in the data. We found clean data. We need to be able to restore data quickly. Now, when we look at testing systems and preparing for this, we need to have processes for how we restore a single object, a file, database, VM, volume, something like that. But also, how do we restore at scale? If you've never thought about how am I going to restore 200 terabytes of VMs within a specific SLA that I've got defined, you probably want to start thinking about that. That's why we typically recommend having a local copy that's immutable as well as an offsite copy. Because how fast can that data be restored? But we also need to test and understand the limitations of each of our data copies. So if I restore from my primary copy, my secondary copy, my offsite copy, how do they differ? Because you need to be able to set realistic expectations around recovery and have a process and have tested that regularly so that you're comfortable with those processes. All right, so we've got data. We've hardened our infrastructure. What about the ability to actually get to my applications and data? So networking is one of the challenges I run across pretty consistently across customers. I had a large county customer here in Colorado where I'm based, where they had 2 data centers. They were very proud of being resilient. But when we dug in and did an assessment to really look at how they were architected, it turned out that, well, that was 1 data center and 2 buildings. The network was stretched across in very archaic architectures. They had really just a single firewall pair that could ever be active, so only one side could work. Um, they were not all that resilient from a networking and connectivity standpoint. So when they finally did, and they actually lost one of their data centers due to a power failure, the entire other data center just went offline as well. They had zero availability during this until they got power back online. And of course, this is impacting things like the sheriff's office, public safety, the jail. I mean, there's a bunch of impacts around this. So when we start to look at this here, and resilient networking for DR is that we need to have availability of the network, but we also need to have predictability so that we know how we can fail over. So that, routing fails over, security policies are there, inbound, outbound paths across, WAN, internet, partners are all pre-engineered and tested ahead of time. And this comes down to just a few things here. Admittedly, we could probably spend an entire 4 or 8 hours just talking through data center architectures for resiliency in the network, but there's a few key items here. So diverse connectivity. Basically, don't introduce single points of failure in the environment. Have the ability to understand how circuits will fail for different types of services, whether it's, WAN traffic, partner traffic, cloud connectivity, internet connectivity, and also your routing supports fast, clean cutover. So we don't want to have it where we have to go reconfigure networks just to be able to push that traffic across. It doesn't help us very much. So having that dynamic routing, good route advertisement, consistent VRFs across sites so they can fail over if we've got multiple sites. This applies whether it's in the cloud or on-prem. Workload mobility. So modern fabrics if you're on-prem, infrastructure as code if you're in the cloud. Basically, technologies like VXLAN have been hugely beneficial in the data center. If I can have gateways active at both sides and I can stretch my layer 2 networks across, and workloads, depending on where they are, go out of the local firewall sets or the local routers, that's drastically easier than trying to figure out how I reconfigure or run HSRP to push traffic across or anything else. So looking at modernizing that. If you're in cloud environments, being able to codify how the networks are built and replicate that. That makes it very easy for us to start to build multi-AZ or multi-region availability. Security policy, if you failed over and now suddenly you have inconsistent objects, IPs may be changed. Maybe your NATs don't work anymore. Your external IPs are different. You need to work through that entire policy ahead of time. Have a plan for it. Ideally, centralize and do a policy as code approach so that you can codify a lot of these changes and make it easier on your teams. Again, simplify it. Making sure your inbound and outbound services are reachable. I mean, what's your public IP strategy? Can you move that public IP block? Are you looking to do DNS, global load balancing? What does that look like? And how do we continue to maintain the security that we need for ingress and egress? And finally, just automate it. So test, again, I mentioned earlier, if you're doing updates to network devices, which you should be doing, a great time to test and be like, hey, what's the impact? What could we be doing better? Where do we need to change our architecture so that we don't have an impact? The worst thing you can have is that if you are scared to death of a device being patched, that's a resiliency challenge that you should be addressing. You should be able to say, hey, I can patch these in the environment. I know exactly what's going to happen. And same as a hardware failure, it won't impact me. It won't take me down. Another big one is make sure you have the ability to get into your devices when they're down. Again, I was working with another organization where they're like, okay, so if we went down, we have to go in and reconfigure all these networks manually, but I don't have resilient HackX to get in. And all my break glass accounts are stored on a password safe that's on a file server at the data center that would be down. Oh dear. So making sure that you have logins someplace that's not going to be impacted. There's a lot of great cloud services these days for that. And that you have config backups also available. What do you have to go rebuild a device or a site because you had multiple equipment failures? You want to be able to put the config back on as quick as possible if you can get replacement equipment. Beyond that, of course, there's the concept of resilient networking, where we want to be able to contain threats. We kind of covered some of that, segment things off so that we can quickly cut links in the event of a cyber attack where, my users suddenly have zero access into stuff, where I've isolated systems. I can stop the bleed real quickly. Have test stacks, hopefully, for systems. So if I'm doing DR, if we're not testing a full stack, and if you've got things like Beam or Zerto where they can build entire test networks that just sit on a separate set of isolated VLANs behind a separate router, do we actually have recovery if we haven't tested it? Maybe not. Maybe it'll work, maybe it won't. So it's good to have built networks ahead of time that you can actually do failover tests without impacting production. Test that DR site if you've got it. Same thing for cyber recovery. Think ahead and build some recovery networks. They're typically out there. They sit behind a firewall with a couple of VLANs. They have the ability for us to turn up a VM inside of them, run our EDR tools, our incident response tools against it. Once it's clean, it gets moved back into production. That's a great asset to have ahead of time. It speeds up incident response and cleaning of systems if needed, and where you're not struggling to try to build this when you're trying to fix everything else in the environment at the same time. All right, let's see the last. So overall, when you start getting into cyber resilient disaster recovery, we need to think about modern disaster recovery has to incorporate the cyber incident recovery as well as traditional disaster recovery. This means that we need to make sure data and IT infrastructure systems are all available, that we have processes in place to clean systems, that we understand what we need to do to clean systems. And really, we design our recovery plans and our infrastructure instead of around the assumption that everything's good, we just fail over, assume that everything that's connected might be compromised, and how could we recover? Because really, if we cover that scenario, we'll be fine in a physical disaster as well. We'll already know how to get systems, do our validation checks, bring stuff online. But in a cyber attack, it means we now know how to do our validation checks, clean if necessary, isolate if necessary, and recover clean. So how do we get started on this? Now, the worst thing you can do with DR is try to take a big bite and do it all at once. Unless you've got a lot of buy-in, that's very hard to do. And really, a lot of organizations and shops maybe don't need a full DR. They're like, we can be good for a day or two if we had a full outage. Maybe we can, use something that's a little bit easier, cheaper, or maybe I'm more worried about cyber attacks and physical disasters. So one way to get started, that doesn't take a lot, is to take the simplified DR path. This is typically IT driven, may not have a lot of business drivers or involvement in it, but hopefully at least IT leadership all the way up. We may have a limited budget, and it's really focused in on how do we protect the data, restore it, how do we do those fundamental pieces that we covered, and then how do we have a very basic plan on how to recover. And I'll dive into that a little bit more here in a second. The other way, and if you especially have two, DR data centers today, and you've maybe got a loose program, is to actually go through a full DR program. These are typically business sponsored. It's a formal program that's been developed. It's got budget allocated and available to it. It incorporates those DR entire infrastructure and systems, and comprehensive DR planning documented as part of it. The simplified one, this is where I see a lot of smaller organizations at least start. If you're thinking you still want to go to the full DR path, this is still a good place to start. Let's get that secure infrastructure foundation built. Start with the basics. Build your network so they're resilient and they're ready to go. Fantastic. Go through and understand what you're protecting, how you should be protecting it, implement those features of those modern data protection, make sure you've got those data copies out there, and that you have plans on how to get the data back if you need to. You put all those together, that's pretty solid. You can get data back, you can connect to it, and you've got pretty good infrastructure to prevent attacks. All you need to layer on top then is building some quick action plans. These are really 1-2 pages. This is how I get started at recovery for different scenarios. These are great to build during a meeting. Pull your team together and say, all right, We need to figure out how to recover from, let's say, our data center failure. What would we do? Or how would we recover from a primary storage failure or a key network device failure? And then just get down some high level steps to at least get you started, get you moving, understanding there's going to be hero antics if you went through one immediately, but then start to iterate it. These can grow into more DR plans as you get forward. And usually this is done through testing those restores, testing those recovery plans, making sure the team is aware of what actually exists out there. What can we do? How do we get into stuff if something's down? And then exercising, things like tabletop exercises. We do them on the cyber side. You should be doing them on the DR side too. The same thing where we walk in the room and say, all right, we got a notification this morning from our systems team that, well, they can't get to any of the monitoring systems and nothing seems to be responding or pingable at the data center. Cool. How do you start? What are you going to look at? Just going through those exercises can help you refine quick action plans, can help your team think through of what would we do first? How would we respond to that? And you take that and you continually improve. You take those feedbacks, you build better plans, you change your networking, design, you build more secure foundation, you start to build justification for more budget and slowly build it out. Now, if you have a big budget, go through that entire DR plan process. That's typically the whole discover and assess, looking at risks and business impact, assessing the systems, figuring out a strategy, figuring out the gaps, architecting and then building out the infrastructure and the DR plans, and then, of course, training, testing, and exercises. That's a big way to go. These take a fair amount of work, but they incorporate a lot of the same features. Like I mentioned, quick action plans. Well, these are very quick recovery plans. You might have built those previously. You might have your update and maintenance schedules that you are working through that helps you give you feedback. You might have data protection in place. You might have secure management plane, infrastructure systems, security. All these pieces layer on top. So even if you start simply, you can always evolve it over time, bit by bit. But every little bit that you take with action gets you more resilient and starts to build towards that disaster recovery in a modern sense. Continuous improvement, mentioned it briefly, but really it comes down to that testing, training staff, talking through plans, running exercises, building out that roadmap for improvement. And really, one thing I see missing in a lot of organizations as well is having an IT or DR risk register across the team. If there's an issue, if there's a risk, if there's something that we found that might be causing problems during patching, put it in a risk register and review it with the teams, track it, track remediation. That gets visibility. It's very similar like problem management in an ITSM framework, where now we're treating risks as a problem. We figure out how to remediate them. We figure out how to apply treatments. All right, finally, if you do nothing else, here's some great tasks that you can start with. If you're still like, wow, I haven't done a lot of this stuff. When we talk through with our customers, there's these 6 areas that we cover a lot. Like, do this first. Don't get stuck in trying to build everything. Get your data protection immutable, protect the management plane where you can, get that lifecycle vulnerability management in place, make sure your networking can survive outages and failures, get that logging and visibility, and then really have some level of quick action plan for what you do first, how you get started. If you guys need additional help or you want to learn more about this, feel free to reach out to us at ANM. We offer free workshops. A lot of these are like half-day workshops where we'll come on site, work with your teams across teams, and really talk through what does this look like in depth? How would it work in your environment? If you're wondering where you are, how you get forward, we offer comprehensive assessments. These are typically paid engagements, but go in very deep to giving you roadmaps. Looking at solutions and services as well would come out of that. So we're here to help. We love to just consult and help you guys evolve without hopefully having to spend a lot on equipment or systems if you can't afford it. It's use what you have, evolve your infrastructure, evolve your processes and your technology. So that will wrap it up. I see we've got like 4 minutes, so not a lot of room for questions here today, but definitely want to thank WRITA for letting us present here today and cover this. Hopefully it was useful for everybody. Are there any Q&A or questions out there, Amanda, that we see sitting, or are we good to go here for everybody? And feel free to type some in. We've got 3 minutes.
I don't see any just yet. But yes, if
Perfect.
you guys have any questions, if not, you guys can see David's email right there. You can reach out to us on ANM, of course, with Rita as well. And we will definitely have some follow-ups for you guys. So keep a lookout for that. Thank you, David, and thank you, Rita, for letting ANM host today.
Absolutely. Thank you, everybody, for attending. Appreciate it.
Yeah, thank you, David. Thank you, Amanda. Thank you, A&M, for sponsoring this webinar. It's been a lot of great information in there, David. So I appreciate that. And it doesn't look like we have any questions here. So for the attendees that are still here, look forward to further webinars. We try to have these webinars the first Wednesday of each month. This was a particular case that we were able to work with A&M on this one here. So with that, have a good day, and we'll see you another Wednesday.
Perfect. Thank you.